Welcome back. This is Mrs. Rubright with Algebra 1 Honors, and today's lesson is 4-5, Exploring Direct Variation. Alright, so we're going to just skip past this graphing calculator portion since you guys don't use graphing calculators. And we are going to pick up on page 205. So we're going to look at the parent absolute value function. Okay, so the absolute value function. So if we are thinking about absolute value, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of negative 1 is 1. The absolute value of negative 10 is 10. 10 is 10, and so on. So it always looks like this. It's always going to be a V. Okay? So what is the domain of f of x equals the absolute value of x? So once again, the absolute value of x looks like this, right? So the domain is your x values. Your domain is x such that x is what? An element of real numbers, or x is all real numbers, right? It covers every x. It goes in, it opens up forever in both directions. Every single x value is going to be affected or included, correct? So, what about the range? Your range, y such that y is greater than or equal to 0, right? It only includes the positives. It starts at 0 and it's both going up. So none of these negative y values ever get hit. It's only going to be y is greater than or equal to 0. Okay? If you fold the graph over the y-axis, so you're folding it on your y-axis on this vertical line right there, then the two halves will match up perfectly. This graph is said to be symmetric about the y-axis, right? Explain why it makes sense that f of x, or y, equals the absolute value of x is symmetric about the y-axis. Because whatever x value you put in, if it's positive or negative, it'll always give you a positive output. So if you put in 1, you get 1. If you put in negative 1, you get 1. If you put in negative 100, you get 100. If you put in 100, you get 100. Because the distance that absolute value is the distance the number is from 0. So if it's positive or negative, it's still the exact same distance from 0, whether it's the number or its opposite. Okay? So to write this in English, right, to put this into words, we can just say that every number and its opposite have the same distance, or are the same distance, from 0. Right? So that's why it's going to always give you that nice mirroring. For what values of x is the function increasing, and for what values of x is it decreasing? All right, so this thing is going to increase for what? So it's going to be increasing for x is what? For x values that are greater than or equal to 0, right? From here on, greater than or equal to 0. And it's going to be decreasing when? X values that are what? Less than or equal to 0. You guys see how this is a decreasing? It's a negative slope. This is a positive slope. Sometimes they like to write things in interval notation. So like for my x values, it's going from negative infinity, it's decreasing from negative infinity to 0, and it's increasing from 0 to positive infinity. And that's kind of how they write it. It's not really teaching you this yet, but just to kind of put it out there. Do you guys remember that from ever before, or not really? I think it's new. So when it's including it, it's a bracket, and when it's not including it, it's so if it's like a greater than or less than but not an or equal to, it's a parentheses. Infinity is always a parentheses. It's always open-ended. So you can see it's decreasing from negative infinity to 0. It's increasing from 0 to positive infinity because it's going on forever in terms of those x values. So just another way of writing it. Graph the absolute value function using the same coordinate plane. The graph of the parent function, y equals the absolute value of x, is shown in gray. So if we're doing y equals 2 times the absolute value of x, let's see, if we put in a 0, we're going to get 0 times 2, or 0. If we put in a 1, we're going to get 2. If we put in a 2, we're going to get 2 times 2, which is 4. If we put in a 3, we're going to get 3 times 2, which is 6. Negative 1 is 1. 1 times 2 is 2. Negative 2 is 2. 2 times 2 is 4. Negative 3 is 3. 3 times 2 is 6. So you get this nice mirroring. Do you guys see how from here and here it's mirrored? Okay, so we have 0, 0. We have 1, 2, and negative 1, 2. We have 2, 4, and negative 2, 4. We have 3, 6, and negative 3, 6. So this is a vertical stretch by a factor of 2. Okay, so this is a vertical stretch by a factor of 2. Or by 2, right? It's a vertical stretch of 2. You guys see how it's stretched vertically? It's thinner, right? Compared to the parent function, this right here is y equals the absolute value of x. This is y equals 2 times the absolute value of x. So all of these x coordinates are multiplied by 2. So like instead of it being at 1, it's at 2. Instead of it being at 2, 2 times 2 is 4. Instead of it being at 3, 3 times 2 is 6. Do you guys see how it's vertically stretched by a multiple of 2? Or however you want to say that. Okay, so then this one, it's going to be the same thing. It's vertically stretched, but do you see this negative? It's reflected. So this is reflected over the x-axis and vertical stretch of 2. Okay? So this is going to be the same one that we just drew, but so instead of 4, it's at negative 4. It's going to look like this. Y equals negative 2 absolute value of x. So let's prove it. So if I put in a 0, I'd have 0, comma, 0. If I put in a 1, I'd have negative 2. If I put in a 2, I'd have negative 4, negative 6. So I'm just taking these and making them negative. Make sense? So knowing parent functions and the rules of what's happening to them, it's really easy to graph these things. The graph of the parent function y equals absolute value of x includes the point negative 1, 1 because f of negative 1 is negative 1, the absolute value of negative 1, which is 1. The corresponding point on the graph, f of x equals 2 times the absolute value of x, is negative 1, 2. Because g of negative 1 equals 2 times the absolute value of negative 1, which is 2. In general, how does the y-coordinate of a point on the graph of g of x equals 2 times the absolute value of x compared to the y-coordinate on the point on the graph of blah, blah, blah? So it's going to be vertically stretched by a factor of 2. So you just multiply your y-coordinate times 2, right? You multiply the y-coordinate by 2. Describe how the graph of g of x equals to absolute value of x compares to the graph of blah, blah, blah. Use the word stretch or shrink and include the direction of the movement. So it's a vertical stretch of the graph of f of x. So g of x, so I'll just say g of x. G of x is a vertical stretch of the graph f of x, right? G of x is a vertical stretch of f of x, right? What other transformation occurs when the value of a in g of x equals a to the absolute value of x is negative? So then it would also be reflected. Reflection across the x-axis. Graph the absolute value function using the same coordinate plane. The graph of the parent function is shown in gray. All right, so this is y equals the absolute value of x. So this is 1/4. What do you think is going to happen with 1/4? If I'm multiplying everything by 1/4, it's going to stretch or shrink? Stretch or shrink? So 2 is a stretch. What do you think 1/4 is? Shrink. 1/4 of something. It's a quarter of it. It's smaller. So, like, 0, 0 is going to stay 0, 0, but, like, so when I plug in a 0, I'm still going to get 0. But if I plug in a 4, 4 times 1/4 is 1, right? So 4, 1. 4 used to be at 4. 4 divided by 4 is 1, right? 4 times 1/4 is 1. So, like, 8 used to be at 8. And 8 divided by 4 is 2. So it should be at 2. Well, let's double check that. If I plug in an 8, absolute value of 8 is 8. 8 times 1/4, 8 divided by 4 is 2. See how that's working? So it's vertically shrunk, which means it gets fat because you're pushing it down. And then this is going to be nice and mirrored. And this is y equals 1/4 absolute value of x. So this is going to be your negative 4 gives you 1, positive 1, right? And positive 2. So the absolute value of negative 4 is 4. 4 divided by 4 is 1. Absolute value of negative 8 is 8. 8 divided by 4 is 2. All right, so then what's the difference between the next one? It's going to be the same thing, but it's going to be reflected, right? So this is going to be negative 4, negative 1. You're going to have 8. When you plug in an 8, you get negative 2. Is this making sense, guys? How does the y-coordinate of a point on the graph of g of x equals 1/4 of absolute value of x compare with the y-coordinate on the graph? So it's 1/4 the height, right? You multiply the y-coordinate by 1/4. Describe how the graph of g of x equals 1/4 x compares with the graph of y equals absolute value of x. Use either the word stretch or shrink. Vertical shrink of 1/4. Right? What other transformation occurs when it's negative? It reflects over the x-axis. Compare the domain and the range of a to the absolute value of x when a is greater than 0 and when a is less than 0. So when a is greater than 0, it's going to be a what? When a is greater than 0, it is a vertical stretch. When a is less than 0, it's a vertical shrink. What happens to the domain? The domain is always all real numbers on these, right? Your range, your y values, if a is greater than 0, it's going to be x is greater than or equal to 0. And for a is less than 0, it's going to be reflected down, so your x values are going to be less than or equal to 0, right, for your range. Why am I saying x? These are y's, sorry. Y. Range is y. Domain is x, range is y. Your x is always going to be all real numbers. Your y's, if it's going upward, it's going to be the positives, and if it's going down, it's going to be the negatives, right? Your y's are less than or equal to 0. All right, so summarize your observations about the graph. All right, so when a is greater than 1, we know it's a vertical stretch, right? When 0 is less than a, which is less than 1. So that basically, if it's a fraction, right? If it's a fraction, it's a vertical what? Shrink. Okay, and no, it's not reflected. What about if it's a negative fraction? It's a shrink. And it is reflected, right? And if your a value is less than negative 1, it's a shrink. Or sorry, 1, so that's going to be a stretch, right? Vertical, it's going to be a number greater than 1, so it's vertical stretch. And yes, it's reflected. The negative part reflects it. If it's a number greater than 1, it's a stretch. If it's a number greater than 0, less than 1, it's a shrink. If it's negative, it's reflected. If it's positive, it's not. Make sense? All right, so write the equation of the absolute value function whose graph is shown. Use this point to find A. Do not pack up until I tell you to do so. All right, so this is your x, this is your y. All right, so for g of -4, so we're plugging in -4 for our x. Okay, so we would have so what do they want me to plug in? So they're having me plug in the -4 here, right? A of -4. So I'm going over to -4 for my x, and I'm getting -3 for my y. So A is -3 over 4, because I'm going to literally, to solve this, I'm going to divide by -4 on both sides. Do you see that? So -3 over -4 simplifies to 3/4. Oh, the absolute value of 4 is 4, positive 4. So it's going to be -3/4. Okay, so the equation for the function is g of x equals -3/4 absolute value of x. So they're just basically having you solve for A. So in order to solve for A, you're just plugging this in for your x, the absolute value of x, and then instead of putting like this, to me, they write this in such a confusing manner, right? To me, this is what I would do. I would use this and this. I would plug in, this is the same thing as y. I'd plug in a -3 here. I would plug in a -4 here. And I'd have -3 equals A times absolute value of -3. So I'd have 3A equals -3. Sorry, that's an x. That's a 4. So I'd have a 4 here. Divide by 4 on both sides. A equals -3/4. Isn't that so much less confusing than the way that they show their work? They like to kind of overcomplicate things, and I'm sorry about that. The fact that the given graph lies on or below the x-axis tells you what about the value of y. It has to be negative. It's going down. It has to be negative. Does this agree with the value of A that you found? Yes. So that's like a nice little double check, right? The angle between the two rays that make up the graph of the parent function is a right angle. What happens to this angle when the graph is vertically stretched? So if it's vertically stretched, it's going to be acute, right? It's going to be less than 90. It will be acute. And when it's vertically shrunk, it's like flattened out, so it becomes like obtuse, right? It will be obtuse. Based on your answers to question 5b, does the given graph represent a vertical stretch or a shrink? So with it being 3/4, it's going to be a shrink, right? So it's going to be a shrink. Does the fact agree with the value of A that you found? Yeah, right? You found -3/4, and it's definitely a shrink. It's made smaller. So 0 is less than absolute value -3/4, which is less than 1. So yes. All right, guys. So your homework is going to be 213 and 214. I hope you guys enjoyed the lesson. Have a great day. Like and subscribe.